For 1900 years, a concrete dome has hung suspended over the streets of Rome, spanning 143 feet with absolutely no reinforcement, no steel beams, no support columns, nothing holding up except its own perfect geometry and ancient engineering genius. This is a Pantheon, and its dome remains the largest unreinforced concrete dome ever built in human history. No modern architect would dare attempt such a structure without steel reinforcement, yet this Roman building has survived nearly 2 millennia of earthquakes, wars, and weather with barely a crack. At the dome's apex sits a 27-foot wide hole open directly to the sky, and when it rains, water pours straight through into the building. This should be a catastrophic design flaw, yet it's actually an intentional feature that makes the entire structure work. The Pantheon represents architectural perfection, so complete that we still don't fully understand how the Romans built it, and modern engineers admit they couldn't replicate it using ancient methods. This isn't just the best preserved Roman building. This is a temple that has outlasted the empire that built it and stands as proof that ancient architects achieved something we've never surpassed. The Pantheon sits in the heart of Rome's historic center, surrounded by cafes, tourists, and the chaos of modern urban life. Walk to the massive bronze doors, and you step into a space that has remained essentially unchanged since Emperor Hadrian completed it around 125 CE. The interior is a perfect sphere. The dome's interior height from floor to oculus is exactly equal to the dome's diameter, creating a hemisphere that could contain a perfect sphere 143 feet in diameter. This geometric perfection isn't decorative. It's structural genius that distributes the dome's immense weight in ways that allow it to stand without any internal support. The Pantheon you see today is actually the third temple on this site. The original Pantheon was built by Marcus Agrippa during the reign of Augustus around 27 BC as a rectangular temple. That building burned down in 80 CE. A second version was built and also burned. Then Emperor Hadrian, who ruled from 117 to 138 CE, completely redesigned the structure, creating the revolutionary dome that stands today. Hadrian was unusual for a Roman emperor. He was genuinely interested in architecture and engineering, traveling throughout the empire examining buildings and probably contributing ideas to major construction projects, including the Pantheon. Interestingly, Hadrian kept Agrippa's name on the building. The inscription across the entrance reads Em Agrippa Leucas Tertum Facit, which translates as Marcus Agrippa, son of Lucius, 3 times consul, made this. Hadrian chose not to take credit, an unusual act of modesty for a Roman emperor. This has caused historical confusion for centuries, with people thinking the building dated to Agrippa's time until modern archaeology established that the current structure is entirely Hadrian's creation. The dome is the engineering marvel. At its base, the concrete is about 20 feet thick. As you go higher, the dome gradually becomes thinner, tapering to just under 5 feet thick at the oculus. This isn't just a reduced weight, though that's important. The varying thickness reflects sophisticated understanding of where structural stresses occur in a dome. The thickest sections are precisely where load are greatest, and the thinning follows the stress distribution almost exactly as modern computer analysis would recommend. The concrete composition changes throughout the dome in ways that show remarkable engineering intuition. At the base, the Romans used heavy aggregate, chunks of travertine tough, dense stone that provides strength where compression forces are highest. As the dome rises, the aggregate becomes progressively lighter. The middle sections use volcanic tuff and broken brick. Near the top, the Romans use pumice, an extremely light volcanic rock that's actually porous and floats in water. This reduces the dome's weight, where structural requirements are less demanding. This wasn't random. The Romans didn't have computer modeling or structural analysis software, but through empirical observation, testing, and accumulated generational knowledge, they understood how domes behave under load. They knew where strength was needed and where weight reduction was beneficial. The result is a dome that's essentially optimized, using heavy material only where necessary and lighter material wherever possible, creating a structure that efficiently manages its own weight. The dome's shape is crucial. It's not quite a perfect hemisphere. It's slightly flattened, a profile called a segmental dome. This shape happens to be nearly optimal for distributing loads in an unreinforced masonry dome. The geometry ensures that forces flow through the structure in compression, which stone and concrete handle well, rather than tension, which would cause cracking. Every element of the dome is being pushed together rather than pulled apart. The interior surface features coffers, recessed square panels arranged in 5 rings of 28 coffers each. These aren't just decoration, though they're beautiful. The coffers reduce weight by removing concrete that isn't structurally necessary. They also create a waffle-like pattern that stiffens the dome, similar to how corrugated cardboard is stronger than flat cardboard. Each coffer has sloped sides, which means more concrete near the base where loads concentrate, and less material in the centers where stress is lower. Then there's the oculus, that mysterious opening at the top. 27 feet across, it's open to the sky with no glass, no covering, nothing. Rain comes straight in, and when there's a heavy downpour, it looks like a waterfall pouring from the heavens into the building. The floor has subtle drainage to channel water out, but this seems like poor planning. Why leave your building open to the weather? The oculus serves multiple purposes. First, it dramatically reduces the dome's weight by removing material at the very top, where the dome curves most sharply. Second, it eliminates what would otherwise be the dome's most structurally challenging point, the apex where a closed dome would experience maximum tension stress. By opening a large hole, the Romans converted that problematic point into a simple compression ring. Third, the oculus provides the building's only natural light, and the way light moves across the dome's interior throughout the day creates an ever-changing spiritual experience. But there's a more subtle genius to the oculus. The opening allows the dome to breathe. Temperature changes cause expansion and contraction in concrete. A sealed dome would build up internal stresses from these thermal movements. The oculus releases those stresses. The dome can expand and contract slightly with temperature changes without developing cracks, because it's not a closed system. The Romans probably didn't understand thermal expansion theoretically, but they may have observed that buildings with openings weathered better than sealed structures. Construction of the dome required temporary wooden formwork, essentially a massive mold that supported the concrete while it cured. Building this formwork alone was a monumental undertaking. The wooden structure would have required thousands of precisely cut timbers assembled into a dome-shaped framework, reaching 143 feet across and rising 71 feet above the floor. The engineering required just to build the temporary support that would hold the dome until it hardened was itself extraordinary. The Romans poured the concrete in horizontal layers, probably working continuously around the dome's circumference to avoid cold joints where separately poured sections meet. Each layer had to partially cure before the next was added to prevent the weight of wet concrete from overwhelming the formwork. This meant construction was a gradual process, possibly taking years just to complete the dome. Workers mixed concrete, hauled it up ramps or scaffolding, poured it into the formwork, and waited for it to set before continuing higher. The moment when they removed the formwork must have been terrifying. You spent years building this massive wooden structure, pouring countless tons of concrete, and now you're going to remove the supports and hope the dome holds. If calculations were wrong, if the concrete wasn't properly cured, if the aggregate wasn't distributed correctly, the entire dome could collapse catastrophically. The fact that it didn't, that it has stood for 19 centuries, validates every decision the Roman builders made. The forces at work in the dome are enormous. The weight of all that concrete creates tremendous outward thrust at the base, trying to push the walls apart. The Romans addressed this with massive walls 20 feet thick at the base, creating enough mass and friction to resist the outward thrust. They also incorporated 8 relieving arches within the thickness of the walls, invisible from inside and outside, that channel loads down to 8 massive foundation points. This distributes the dome's weight strategically rather than uniformly. The Pantheon has survived remarkably well considering its age and the disasters Rome has experienced. It endured the fall of the Western Roman Empire, the chaos of the early Middle Ages, multiple earthquakes, and centuries of neglect. Its survival is partly due to being converted to a Christian church in 609 CE. As the Church of St. Mary and the Martyrs, it remained in use and was maintained throughout periods when many Roman buildings were abandoned or cannibalized for building materials. However, the building hasn't escaped entirely unscathed. The original bronze ceiling tiles that cover the exterior of the dome were removed in 663 CE. Pope Urban VIII notoriously stripped bronze from the portico's ceiling beams in 1632 to make cannons for Castel San Angelo and create the massive bronze canopy over the altar in St. Peter's Basilica. This led to Romans saying, "What the barbarians didn't do, the Barberini did," referring to Pope Urban VIII's family name. Despite these removals, the structure itself has required remarkably little repair. Small cracks have appeared over the centuries, and there's been some water damage and surface wear, but the dome's structural integrity has never been seriously compromised. No major reinforcement or reconstruction has been necessary. The building stands today essentially as the Romans built it, still performing its function, still stunning visitors with its beauty and scale. Modern analysis using laser scanning, ground-penetrating radar, and other technologies has revealed details about the Pantheon construction that weren't previously visible. We can now see how the Romans incorporated broken brick and pottery into some sections, possibly to adjust weight or use available materials. We can detect variations in concrete composition and identify repair work done in different periods. But even with all our technology, questions remain about specific construction sequences and techniques. One enduring mystery is how the Romans achieved such precision without modern surveying equipment. The dome's geometry is remarkably accurate. Measurements taken at different points around the diameter vary by less than a few inches. Impressive precision for a structure built with hand tools and eyesight. They must have had sophisticated surveying methods and careful quality control, checking and rechecking measurements throughout construction. The Pantheon has inspired architects for 2 millennia. Brunelleschi studied it before designing Florence's cathedral dome. Andrea Palladio measured and drew it. Thomas Jefferson used it as inspiration for the rotunda at the University of Virginia. Countless government buildings, churches, and monuments worldwide echo the Pantheon's dome. Yet none have matched its combination of size, durability, and absence of reinforcement. Modern concrete technology is fundamentally different. We use steel reinforcement to handle tension forces that concrete alone cannot manage. This allows more daring designs, but creates durability problems. Steel corrodes, especially when exposed to moisture and salt, causing the concrete to crack and fail. Most modern concrete structures have design lives of 50 to 100 years, after which they require major maintenance or replacement. The Pantheon is 19 times older than the longest-lasting modern concrete buildings, with no end to its lifespan in sight. Could we build the Pantheon today using Roman methods? Probably not successfully. We could certainly construct a similar dome using modern materials and techniques with steel reinforcement. But attempting to replicate it using only Roman concrete, no reinforcement, following their construction methods, would be extraordinarily risky. We don't fully understand all their techniques, and modern builders lack the generational knowledge and hands-on experience with unreinforced concrete domes that Roman builders possessed. The building teaches humility. Here's a structure nearly 2,000 years old that remains unsurpassed in specific ways. Modern engineering has achieved remarkable things the Romans couldn't imagine, but in the specific challenge of building large unreinforced concrete domes, they achieved a peak we've never matched. This suggests that technological progress isn't uniform or inevitable. Some capabilities can be lost when the social structures supporting specialized knowledge disappear. Standing inside the Pantheon, looking up at the oculus with light streaming through, you experience space almost exactly as ancient Romans did. The acoustic properties, the way light moves across the coffered ceiling, the sense of geometric perfection, the feeling of being inside a perfect sphere, all unchanged. Few places allow such direct connection to the ancient world. The Parthenon in Athens is magnificent but is a ruin. The Colosseum is impressive but is fragmentary. The Pantheon alone remains complete and functional, still serving essentially its original purpose as a spiritual space. The building embodies Roman pragmatism and ambition. They wanted to create the largest possible enclosed space, so they engineered a dome to the limits of their materials. They wanted divine presence symbolized, so they opened the dome to the heavens. They wanted permanence, so they built with materials and techniques meant to last forever. And they succeeded beyond anything their successors have achieved in the specific domain of unreinforced concrete domes. Every year, over 6 million people visit the Pantheon, far more than visited in antiquity. It's free to enter, still functioning as a church, still hosting masses and concerts, still part of Rome's living fabric rather than a dead monument. Rain still comes to the oculus. Light still circles the walls, tracking the sun's movement, and visitors still crane their necks upward in wonder at that impossible suspended dome. The Pantheon reminds us that ancient people were not primitive. They were fully human, as intelligent and creative as we are, working with different knowledge and tools, but capable of achievements that challenge our modern capabilities. The dome above your head in the Pantheon is a silent teacher, showing that 2,000 years ago, without computers, without steel, without most of what we consider essential for such construction, Roman engineers created something perfect that still stands, still functions, and still inspires. That's not ancient history. That's timeless engineering genius.